Welcome back to Summarize Science. Ever wondered why generating a high-quality AI image can feel like it takes forever? Many of the best models, called autoregressive models, build images one tiny piece at a time, like a super slow, ultra-precise printer. This token-by-token process creates incredible detail, but is painfully slow. But what if there was a way to speed it up without making the images look worse? Researchers have introduced a new method called HAWK that does exactly that. The core problem is that images are fundamentally different from text. A technique called speculative decoding works great for speeding up language models by having a smaller, faster model draft text that a larger model then verifies. However, this doesn't work well for images because they have a complex two-dimensional structure. An image token's context isn't just what came before it in a line, but also what's above it. This is where HAWK gets clever with a new framework called Spatial Speculative Decoding. Instead of just trying to guess the next piece of the image horizontally, HAWK's draft model looks in two directions at once. It speculates both horizontally for what's next in the row and vertically for what's in the row below. This dual-direction approach creates a much richer set of predictions for the main AI model to check, all in a single step. The researchers discovered that when an AI generates an image, it pays a huge amount of attention to the pixels directly above the one it's currently creating. This chart shows that attention spikes not just for recent tokens, but for the entire previous row, which is highlighted in the red box. HAWK is specifically designed to leverage this crucial spatial information that other methods ignore. So, does this actually work in practice? The results are fantastic. This table shows that HAWK achieves a speedup of about 1.7 times compared to the standard, slow method. Crucially, the quality scores, FID and clip score, are almost identical to the original model. This means we get significantly faster generation without any noticeable drop in quality or creativity. Let's look at the visual proof. In these side-by-side comparisons, you can see images generated by the baseline model and by HAWK. It's nearly impossible to tell the difference. The images from HAWK are just as detailed and coherent, proving the method's effectiveness. So, let's recap the important points. Standard high-quality image generation is slow because it works piece by piece. HAWK accelerates this process by cleverly guessing future image pieces in two directions at once, using spatial context from the pixels above. This results in a massive 1.7x speedup with virtually no loss in image quality. What does this mean for the future? This breakthrough could lead to much more responsive and accessible AI art tools, faster in-game asset creation, and quicker design prototyping. HAWK represents a major step towards making powerful, high-fidelity AI generation practical for everyday use. Thanks for watching Summarize Science.